Hi guys, welcome back to the next part of the series. Today we're going to continue with the cloth dynamics and we're going to start doing the pants. However, before we jump there, I need to explain how cloth dynamics work here inside of ZBrush. So let's grab a sphere real quick and let's make this a polymesh 3D. So this is just a very basic sphere in the middle of nowhere. If we go here and we append a plane, let's go here to our plane 3D, there we go. And we make this plane a little bit bigger, and let's rotate this 90 degrees so that it's perfectly flat. ZBrush several years ago actually added a very cool thing where they want to compete against other softwares like Marvelous Designer, and they added dynamics. So now we have a way to generate cloth and this sort of fabric or a smooth effect on the surfaces to make our lives a little bit easier when sculpting cloth. You can still do it the old fashioned way where you would literally sculpt every single wrinkle, but this is a great way to get a starting point and then polish from there. So the first things that we need to understand is right now, if we want to see the other side of the plane, we can go all the way down here to display properties and use a double. It's very important when we're working with cloth to try to keep things as a single-sided geometry, because dynamics, collisions, and all these things, they don't really work when you have multiple sides. So it's better to keep it like this, and later on, if we need to add thickness to it, we can add it very easily. So if we go to the dynamics tab right here on the top part of the element, you can see we have a lot of options. I'm gonna dock this on the side right here, and we really don't need the brush one. And this is the stuff that we're going to be using to generate our dynamic function. The way this works is very simple. Let's actually turn on perspective so that we can always see the plane. So when we hit a run simulation, the plane in this case is going to simulate, and as you can see, it's going to fall flat into the ground. If we press Ctrl C and let's say we rotate this thing a little bit, when we run the simulation, you can see how when it touches the ground, it does it in a very interesting way. But right now it's not reacting to the sphere. Why is that? Well, because we haven't told ZBrush that we want all of the other tools to be actually affected by the simulation. That's why we need to use this thing called collision volume. So for a little element like this plane to be affected by other things, we just click collision volume. This creates a collision volume based on the other subtools that are visible right now. If I hit run simulation now, you can see that we get this, which is a very cool simulation. And we get this very nice wrinkles and folds going around the whole thing. So here's the first lesson about simulations and cloth dynamics inside of ZBrush. If you're using cloth dynamics, you need to understand that the more resolution we have, the nicer the effect will be. However, the slower the whole simulation is also going to be. So if I, for instance, say Ctrl D to give a subdivision to this plane and I run the simulation, you're gonna see that the wrinkles that we get are a lot nicer, but it took just a fraction of a second longer, right? Let's go Ctrl C, let's do Ctrl D again, so that's 3 subdivisions right now. And if I run simulation, it's a lot slower, but you can also see that the wrinkles are really clean and smooth. So that's the way in which we can, that's one of the ways in which we can control the effects of our simulation. If we go back to subtool, I'm gonna do Ctrl C, or actually not subtool. Let's go to subdivision level 1, and I'm gonna delete higher. There's a very cool thing that we can use here inside of the geometry options to work with low subdivisions but see a high definition result. And it's the following. If we run the simulation and we got something that looks interesting like this one, but we don't want to see this faceted effect, we can go to dynamic subdivision. And dynamic subdivision is, if you guys are coming from Blender, it's kind of like a modifier. It's not permanent. Even in Maya, when you press number 3, it's not permanent, but you can see how this thing will eventually look. So if I hit dynamic, as you can see, we're going to get a very nice effect, even though we don't have this active geometry right now. And I can press Ctrl C, turn it on right now, and do the simulation. As you can see, the simulation is still going to be very fast, and the result is going to look a lot smoother and a lot better than what we had before. So this is the dynamics of it. Now, remember how I mentioned that we can add thickness later? Well, we can add thickness right here. If I start adding thickness here, let's go for a really strong thickness. Well, not that strong. We can add a little bit of thickness to the whole cloth. And if we are gonna 3D print this or whatever, this is what we would be expecting to have. So dynamic subdivision is very cool. There's a shortcut, the letter D, to turn it on. As you can see right here, I'm gonna say always yes. So as long as I don't have subdivision levels, when you press the letter D, you activate this, and then if you press Shift D, you turn it off. So D to turn it on and Shift D to turn it off. Very cool thing to do, or very easy way to do it. Now let's go Control C here once again, and I'm gonna show you something a little bit more interesting. If we have, let's say, 2 elements, okay, I'm gonna duplicate this thing right here, push this one up here, let's push this one up here. If I try to run the simulation again, you're gonna see that it's not obeying this other sphere, and that's because when we ran the collision volume, it was not actually obeying that particular thing. So we need to recalculate so that it takes the new sphere into account. And now if we do a run simulation, it should take both of them into account. But let's rerun the simulation, and I'm going to press a spacebar. You can press a spacebar at any point to stop the simulation. And I want you guys to see something. When we go here on the sphere, you can see that there's a little bit of a pocket of air between the two elements. And that's something that happens because we have this inflate set to 1. So if I set this to 0, okay, and I do this again, all the way over here, you're going to see that now the simulation is going to be a lot closer to the sphere, but oh, we got a problem. For whatever reason, it ran through the objects and it kind of like embedded itself inside of the object. So yes, we're getting a tighter like effect because it's really close to the surface, but we're not really getting the same like fidelity on the collision calculation. Why is this happening? Well, because we, by reducing the inflate amount, we're telling ZBrush that we want it to be way more precise. However, we're not giving it enough time or enough iterations to make this happen. So up here we have two things that are very important: dynamic or simulation iterations, and over here the gravity strength. So simulation iterations are how many times, I believe it's per second, ZBrush is going to calculate the collisions of your object. If you have a really complex simulation and you have low simulation iterations, then this thing that is happening is going to be happening more often, and you're going to see how the cloth goes through the objects. However, if I were to increase this all the way to the top, which is 1,000 iterations, and I run the simulation, it's going to be slower, but we should be able to, or at least try to minimize the amount of defect that we have. However, as you can see, we are still not getting that. And the reason why is because the strength is very, very strong. So this plane is falling very, very fast into the spheres, which is the usual way it would fall in the real world. But sometimes, especially when doing sculpting or modeling, one of the things that we want to do is we want to have a perfect fit. And to do that, we can reduce the strength, let's say by 5, so to 5. And now the simulation is going to be a lot slower. And this should give my effect a little bit more time to try to get this done a little bit better. Another thing that of course is affecting is the amount of polygons. So the more polygons we have, the more precision we can get. So if we go all the way over here, let's get rid of dynamic simulation. I'm going to control D to give myself once a subdivision, and then I'm going to delete lower. If I do this again, now it's going to be a lot slower, but it should be a lot more precise. And you can see right there, the overlap is not as bad as what we had before. Okay. I'm going to press a spacebar at this point to stop the simulation, and you can see when we turn on dynamic subdiv, yes, we get this, but if we were to turn these spheres off, you're going to see that we get a very, very nice effect. This, of course, is telling me that maybe we do need to have a little bit of inflate, so maybe like a 0.5. Okay, of course, we need to have them visible. There we go. So 0.5, I'm going to recalculate the collision volume. And now, if we run the simulation again, this should fall really, really close to the surface, hold the shape very nicely because we have, again, a low gravity strength and a low simulation iteration, and we get this very, very cool effect. Okay, again, at any point I press the letter D and we're going to get a soft like effect. So this is the technique or the main tool that we're going to be using to build some of the props for our character. However, there's a couple more things I want to talk about. First of all, of course, we have the gravity here. If we turn the gravity off and we hit dynamic simulation, nothing's going to, or sorry, if we hit a run simulation, nothing's going to happen. So in case you want the simulation to work, we need to turn gravity on. Liquify, gravity liquify changes the way gravity works. Instead of being this downwards force, it becomes like a volume, and it's going to give us a very interesting effect. Right now it doesn't seem like much, but once we hit the thing right there, you're going to see how it kind of like slides. There's going to, again, it's kind of like if it was falling inside of a water liquid, and you can see the way the waves and everything propagate. It's a slightly different than what we had on the traditional simulation. So it's just a slightly different effect. Right now the direction, as you can see, is like the normal direction, but it is possible to change the direction to another one. In this case, we're not going to do that. What else is important? We got self-collision. We can increase self-collision if things are going to be going on top of each other. Right now, we're not really going to be using. Oh, the mask thing. This is very, very cool. So if we mask something, let's say I grab my mask lasso, and I mask this border right here. When we run the simulation, that mask effect is not going to be affected. And as you can see now, everything is going to be falling into the spheres, and it's going to be generating some very interesting wrinkles. Now I can stop the simulation, remove the mask, and run the simulation again, and now everything is going to fall. And as you can imagine, this is going to give us a completely different result than what we had before. So playing with mask points and things like that is very important. We can mask again, and if we run the simulation now, everything's going to keep falling except for that particular piece. dynamics. So that's a perfectly valid way to generate some interesting shapes here for our element. Other than that, I don't think there's really any other. Of course, there's more settings right here, but for now, I think that's pretty much what we need to cover right now. Let's just very quickly go to another exercise. I'm going to go here to the character, and let's say we want to work on the torso right here. So if I mask out, I'm going to go to the lowest of division level, and I'm going to mask out like a shirt. Very basic, right? Like just do a very basic shirt here for our character. One of the things that's going to happen, well, of course, here first we need to extract this. So I'm going to go subtool. We're going to extract, and we're going to extract the subtool. 0 thickness, remember, cloth is very with no thickness. So 0 thickness, there we go. Oh, my bad. Delete, okay. Go over here, there we go. So extract and accept. There we go. And you can see it's fairly low poly, so this is perfectly fine. We can work with this, like the dynamic is going to work with this. I'm going to just turn on the chest area right there. And if we grab the shirt here, we can again recalculate volume with a 0.5 of inflate. And if we run the simulation, this is what's going to happen. Now, one of the things, or one of the bad, or not one of the bad things, one of the cool things actually about this whole simulation thing is that we actually have some brushes that work very nicely with this thing. They're called simulation brushes. So if we go B to our brushes, you're gonna find all of this cloth notch, cloth move, cloth hook, cloth fold, cloth inflate, and all of these guys, they work with the dynamic system of the cloth. So for instance, cloth slide, very common one right here. If I want to bring one of these sleeves up, and I use cloth slide, as you can see right here, when I try to move this, it's going to point, or it's going to be pushed towards where this point is, like that, okay? Another one that's very useful is this cloth move is really good. And the cool thing is, as we move this thing along, as you can see, it's going to try to bundle up and create interesting wrinkles that will be quite difficult to sculpt by hand. So it's going to crunch itself because it's literally calculating the dynamics of how this thing would be moving the whole element. So it's a really cool way to generate like wrinkles. Look at how many wrinkles we're creating there with really no like difficulty, right? Now, at any point, remember, we can turn on dynamic subdivision, and you can start seeing all of these wrinkles. So even though we're working with a very low res effect, we can generate all of these very interesting effects, again, without having to worry too much about the whole issue. So later on, if you're doing like a sofa, if you're doing, I don't know, like curtains, like a bed sheet and stuff like that, all of these ones are very cool. Cloth notch is also a really good one. It allows you to just like notch the cloth up. As you can see, we can get some interesting effects, or pull it down. But we pull this down in a sort of like dynamic way. Again, this is not like your normal move brush or clay buildup brush, which we can still use, by the way. At any point, you can use your clay buildup, your smooth brush to remove certain wrinkles. Like, you're free to do that. And then if you want to bring some of those wrinkles back, like, I don't know, like this cloth pinch right there, we can do it. There's a one that's very funny, this one, cloth twister, because it kind of like twists things together into like this, like, I don't know, spirals. So yeah, very fun brushes. Now, we're going to be using some of these brushes and of course the dynamic system to generate the pants for the character and get them as close as possible to a reference I'm going to show you in the next video, so that we can create some very nice looking stylized pants. So yeah, that's it for this one, guys. Make sure to give it a little go, practice a little bit before we go into the pants, and I'll see you back on the next one.